So we did an algorithm. Whenever you do an algorithm, you just need to think about things like how well does it work? Well, obviously it works great because I'm telling you about it. No, we'll see that in a minute. More importantly, for algorithms, we have to talk about things like complexity. So the first question is, this is an easy one, what's the space complexity? That is, how much memory do I have to use? Well, forgetting the image for a moment, the bottom line is I need k to the n bins, all right? So if I have k bins in each dimension, it's k to the n is the number of bins. So we were doing this in 2 dimensions, so it would be k squared. So, you know, if I have about 100, so it's about 10,000 maybe. That should tell you, and this is going to come up in our next lesson, that adding the number of parameters, which increases n in this case, can be very expensive in terms of memory. In fact, also in your problem set, you're going to try to do something and you're going to blow up MATLAB, and then you're going to figure out how to fix it. What about time complexity in terms of the voting? Well, the nice thing is that the voting is linearly proportional to the number of edge points. You run through your edge points and they each vote. And the voting might take a little bit of time, but it's constant, all right? Compare that, let's suppose you're trying to fit a circle, okay? So a circle is defined by 3 points. So if you have some large number of edge points, the number of triples is that number, let's call it q. Q choose 3 would be a very big number, right? Whereas if you do something that's proportional to just q, you're in much better shape. So the idea here is that the time complexity is constant in the number of features or edge points that you've detected.